Okay, we started off with this system of equations. 3 equations in 3 unknowns, x, y, and z, the goal being to find numbers x, y, and z for x, y, and z that satisfy these equations. So, first task, and you should do this yourself without looking ahead if you haven't already done it. A lot of you did it in class, so you're going to be okay with this. But we want to add multiples of the first and second equations in order to eliminate one of the variables x, y, z. Now you should pause and do that. You should have paused and done that. Here's probably the most straightforward way to do it. We take the first equation, we take the second equation, we write them down, and we see that the z's already line up in such a way that if we add the 2 equations, we get an equation from which z has been eliminated. Okay? So there's an equation in the variables x and y. Now, I said just add multiples to eliminate one of the variables. We could have eliminated x. If we just multiply the first equation by -3, we get a negative 6x. Multiply the second by 2, we get 6x. And of course, we'd have to multiply everything else here by -3 and everything else here by 2 in order to maintain the validity of our calculations, in order to not affect the solutions. But that would work. We'd get rid of x. We could get rid of y. Multiply this equation by 2, we get a 6y. Multiply this equation by 3, we get negative 6y. So we could have eliminated y from the 2 equations. So z isn't the only variable we could have eliminated. It's the easiest, but x or y would also have been an easy choice. So you could well have made those choices. However, we'll pick on z for the moment. So we get this equation if we eliminate z. Now, having eliminated z and gotten an equation in 2 variables, a linear equation in 2 variables, we could eliminate z from another pair of equations, any pair of equations. Now, of course, we have a limited number of pairs. In other words, we could eliminate z from the first and third, or from the second and third equations. That's easily done. Probably the first and third is the easiest. That's the choice most people made. So see if you can eliminate z from either the first and third, or the second and third equations, and see what you get. Now what we're going to do here is we're going to use the first and second, so you might want to do that. But you could make either choice. It would work as well one way as the other. Okay, well, here's what we have. Here's our first equation. Here's our third equation multiplied by 4. Why by 4? Well, if we're going to eliminate z, we have minus 4z here and plus z here. If we multiply this equation by 4, then the 4z will line up with the negative 4z, so that when we add these 2 equations, we get an equation in just 2 variables, and you can verify that this solution is correct. Well, now what do we have? We have this equation in x and y. We have this equation in x and y. We can take these 2 equations and write them down, and now we reduce the problem to just solving this system of 2 equations. Okay, so what do we get when we solve the system, the system of these equations? You can do this. We did this last time. Hopefully you've reviewed and you've done the problems in the book and everything you're supposed to, so you know how to solve a system of 2 equations and 2 unknowns. And the easiest way to do that is negative 7 times the first equation is going to give you this equation. And that's going to match up with the second equation in such a way that you have a negative 7y here and a 7y here. You add them together, you get negative 29x equals 19. And we solve the system and we get x equals negative 19 over 29. Now, having obtained this value of x, we can take that value and substitute it into, say, this equation, and that'll give us an equation that we can solve for y, because x is now a number. The only unknown is going to be y. Now, and it wouldn't matter whether we put it into this equation or this equation, we're going to get the same solution for y. Now, having done that, we'll have a value of y, and if we then plug our x value, which is going to be this, and the y value we get out of that process into any of these three equations, we're going to get an equation where x becomes a number, y becomes a number, and we're going to be able to solve the equation for z. And at that point, we'll have an x and a y and a z that satisfy all three equations. And of course, we're going to probably want to check that by substituting our x and y into a couple of equations, or substituting the x, y, z that we get into at least one of the other two equations to verify our solution. We'll continue with that back substitution in the next clip.